So first kind of, the question pattern is that, around interconversion of the stack into the queue and the queue into the stack. So right now, so far we have seen that we have implemented queue using the array. We have implemented queue using the linked list. Now, this is another question in which suppose you have been told that you are allowed to use stack. You are allowed to use a stack data structure. Now you have to implement a queue using the stack operations. Okay. So basically, if you have to implement a you have to implement two operations. So you'll have to implement one is enqueue, public enqueue, and data, and another thing is that public dq, public int dq, and this is queue data structure. I have to basically implement both the methods of enqueue as well as the dq using stack. Using stack. Can you guys think of how can we do it?
So can we use multiple stacks?
Yeah, you can use multiple stacks.
So I think that I will use two stacks, right? So when I'm
Okay,
just yes, so when I'm just enqueuing first, I will push element in the first stack.
okay. So let me draw two stacks here so that we all are following together. So suppose you're saying that I will create two stacks. Okay, so suppose I have a stack one this and I have a stack two this. So this is my stack one and I have a stack two.
So sir, when I'm enqueuing element, I will push the element to stack one.
Okay, so for example, say in the queue we are first saying I'm enqueuing. So I'm indicating enqueuing by E. So I say enqueue one, suppose, right? So if I did one, should I push it to one here?
Yes, sir.
So this can happen. So this can happen in the constant time. O of one time it will happen. Okay. Now, if I suppose again I say E2.
Sir, I will push into S1.
Again you will push into this one. Okay. So again this will happen. So that is sorted. So enqueue operation is happening in my constant time. You are blindly pushing the elements into the stack one and it is happening in O of one time. Very nice.
But
Okay.
I don't
But
think so.
when I do a DQ, how it will happen? What will happen in the case of the DQ?
Sir, it will not happen in like order of one. So in my case, I thought that like I will whenever I had to DQ, I will pop up all the element into S2 and then I will pop element from S1.
So yeah, so basically when I have to implement queue using a stack, there will be few limitations. I may not be able to do both the enqueue as well as the DQ operation in a constant time. That is there. So if suppose you're not worrying about the time complexity thing, then what should happen in your approach? You will try to pop all the elements from here to here. So basically you will pop two here first. And you'll keep on doing till you'll have with only one element in this, and whatever the last element is there, that will be the your result, right? So this will happen in O of n time.
N time.
O of n time. So basically, when you are implementing a queue using stack, you can optimize one of these two. Either you can optimize the enqueue or you can optimize the dq. So in this case, you have optimized the enqueue. So you have made the enqueue as a constant time operation, but the dq is a linear time operation. But if I tell you, suppose I want to optimize on the dq, and you can make because dq is something I'm doing more. So what you do in that case? Are you guys getting my question? In this case, there are two operations, enqueue and the dq. Enqueue is very much optimized because I'm blindly going and storing the element into the first stack, right? So that pushing into the stack is a constant time, so the enqueue is happening in the constant time. So I just do that. In the case of the dq, now there is a problem. So what happens whenever I have to dq, I keep on popping the elements from the first stack till only one element is left, and then that final element is my answer, which I have to return as the dq. Everybody is clear on this?
Yes.
Perfect. So in this scenario, the time complexity of the enqueue is O of 1, which is a constant time complexity, and the time complexity of the dq operation is linear, which is O of n. But suppose if I tell you, I reverse this, I want you to say that I want to more optimize dq, and I can compromise on enqueue. What should we do in that case? So basically, DQ has to be done in a constant sense. So basically, I have to just do a pop, and that should return me the smallest element. That should be my criteria. Okay. So I can take two stacks, stack S1, and I take stack S2. Okay. First of all, first element came, I just go into this one since there is only one element. Now when I have to pushing another element 2 into it. Okay? When I have to push another element 2 into it, what I do is that I start popping all the elements from the 1, okay, and moving it into the S2 till the whole is empty. So it became 1 here. Okay? And after this is done, then I put 2 here. Okay? After this is done, I then put a 2 here. Now again, when I do, again if I have to enqueue 3, and once this is done, I again replace it. So now this is my S2 is full and the S1 is empty. So whatever stack is full right now, I'll try to enqueue again in that. So again, this is having 2 and the 1. It is having 2 and the 1. So what I'll do is that I'll take out 2, I'll take out 1. Okay. The way I try to do is that I'll try to push into the bottom, right? So here I'll again it will push 1 at the bottom, right? And uh, first the 2 will be pushed, and then when I'm trying to push 1 here, I'll try to push 1 into the bottom. So 1 get pushed here. So 1 come here, 2 comes here, and then finally whatever the 3 comes here. So this will take linear time to achieve this thing, as we did in the case of the stack. We saw it last. And but now whenever I have to do a DQ, I don't have to worry about always, what I need to do. Any stack which has the element, I have to just top, remove out the topmost element of it, and that will be a DQ. So DQ will happen in a constant time, but the NQ will become little complex and it will start taking the linear time to solve the problem. Clear?
Yes,
Any
sir.
doubt? I'll again repeat. Okay. So this problem is basically has two subtypes. One when it is more optimized on the NQ and less optimized or compromised on DQ. Another way it is more optimized on DQ and compromised on the NQ. Right. So you need to. We've already discussed the logic. So I expect you guys to implement this problem now. This problem logic we have already done. So writing codes is one of the easiest thing to do. So I am expecting this.